Yo, all right, let's go over questions 8 and 9. Two awesome questions. They look very similar, yet they are very different. All right, so it says a rectangular plot of land is to be fenced in using two kinds of fencing. All right, let's get a pen going here. It says two opposite sides will use heavy duty fencing selling for $3 a foot, while the remaining sides will use standard fencing selling for $2 a foot. What are the dimensions of the rectangular plot of greatest area that can be fenced in at a fixed cost of $6,000? So it's an optimization problem. I recognize that it wants me to find a rectangle with greatest area. So the first thing I'm going to do is I'm going to write down what I want to do, which is I want to max area, right? So now we're talking about a rectangle. So I'm going to draw myself a rectangle. I'm going to label the dimensions, and I can label them whatever I want, but maybe I'll call this Y, and I will call that X. And so now if I want to maximize area, I need an area function. It happens to be the area of a rectangle. So then we know how to do that, right? Area of a rectangle is just going to be base times height, or in this case, X times Y. So that's the function that I want to maximize. Now, just like in class, the issue is we have too many variables. So is there other information that they gave us that'll help us to get Y in terms of X? And the answer to that is yes, right? They told us that the cost of this project, the total cost, is going to be $6,000. And it also gave us some rates here, right? So the heavy duty fencing is going to be $3 a foot. So maybe I'll make the blue fencing the heavy duty fencing, right? So that's $3 a foot. And then the other fencing, right, the standard fencing, we'll make that this little purplish color, is only going to sell for $2 a foot. So then how do I use all of that information to come up with an equation involving X and Y? So let's get after it. Well, let's think about it, right? If, let's just say for argument's sake, let's say I had X was 5. So I had 5 and 5, so I had 10 feet, I should say, 10 feet worth of heavy duty fencing. How much would that cost me? And I think you'd probably say, all right, that would be $3 a foot. You have 10 feet, it's going to be $30. How'd you figure that out? You multiply them, right? So the deal is you don't have 10 feet of the heavy duty fencing. You have X and X, right? So you actually have 2X feet and 2X feet at $3 a foot. This product here would now represent the cost of the heavy duty fencing. So now what do I want to do? I want to add to that the purple fencing, right? So what's the story there? Well, again, if I just made up some number and said, say Y was 4, so I have 4 feet here, 4 feet here, that's a total of 8 feet. So if I have a total of 8 feet and it sells for $2 a foot, that's going to be $16 that I'm going to spend, right? How did I figure that out? Right? I multiplied. Well, all right, I don't have 8 feet. I have Y and Y. I have 2Y feet. And selling at $2 a foot, this represents the cost of the standard fencing. So now when I add these together, I get my total cost, and they said that the total cost was $6,000. So this is what I got. So now I can spruce this up a little bit, right? I'm going to get 6x plus 4y equals 6,000. And so now I want to solve this for y in terms of x, or x in terms of y. It really doesn't matter. It's kind of your call. So I'll solve it for y. So if I solve it for y, maybe the first thing that I do is I do 4y equals 6,000 minus 6x, and then I want to divide everyone by 4. So y is going to equal 6,000 minus 6x over 4. And you can actually spruce this a little bit, right? So it looks like a factor of 2 will go into the numerator and the denominator, right? So if I simplify that, this would be 3,000 minus 3x, right? If I divide both of those by 2 and then divide this by 2 over 2. All right, so that's spruced up a little bit. If I want to go even further, which you don't have to, but maybe I will, right? This 2 divides both these terms. I'm going to get 1,500 minus 3 halves x. Okay, and I could have honestly, I could have broken it up here and did it the same way, or even when I divided by 4 showed that. So kind of a weird way how I got to that, but no matter how you get to it, this is what y is equal to. So now what I can do is I can come back over here to my area equation and say area of x now is going to be x times what I got for y, which is 1,500 minus 3 halves x. Now, if I was doing this problem, I would distribute the x. I'm going to rewrite a of x as 1500x minus 3 halves x squared, okay? And so now that represents the area of this rectangle with these constraints of the cost of the fencing and the cost of the standard and the heavy duty. So that's pretty good stuff. So now you're like, all right, well, what can X be? This is someone asked me this at Extra Help. They said, can you tell me how to get the domain? And there's really no answer to that other than you have to think about it. So what does X represent? X represents a side here, right? So what could X possibly be? Well, it's not going to be negative, right? I'm not going to have negative fence, but could it be 0? And this is a little weird, but yeah, it could be 0, right? 0 doesn't create division by 0 here. So you're like, well, if X was 0, then you don't really have any heavy duty. You have all standard. It's like purchasing just standard fencing, and you would have a rectangle that would have an area of 0 because it literally would just be this vertical line of purple fencing. We would call that a degenerate rectangle. All right, but for the purposes of this, you can let X equal 0. If you don't want to let equal 0, if you have some sort of moral issue with that, well, then just make it open. All right, so you can open up make this a parenthesis here, and then just say, all right, the limit of the area as x goes to 0 from the right would be going to 0, and you're going to get the same thing in the end. Okay, so now this is a little wackadoo. How big can it be? Well, you're going to make it as big as you can make it without having to make another dimension, in this case, y, negative, right? So we don't want y to be negative. So what can I do here? Well, if I kind of just solve this here, right, it looks like 1,000, 6 times 1,000, that would make the top 0. So if I'm any bigger than 1,000, then I'm going to go negative. So we can say that the largest we can make x is going to be 1,000. All right, and again, I can include it. So there's my interval. So now the reason why I chose to close it is because now I have a continuous function, it's a polynomial, on a closed interval. So the extreme value theorem is going to apply. So we'll come over here now and we'll get our candidates. Now our candidates are the endpoints, but they're also our critical points. So to get the critical points, you have to take the derivative. So the derivative is going to be 1,500 minus 2 times 3 halves. That's what, 3x to the 1. Set this equal to 0, right? To get your critical points, maybe I pull out a 3. I get 500 minus x equals 0, and maybe we can see here that x is going to have to equal 500. So that's our only critical point. It's actually a stationary point as well because it specifically makes the derivative 0. So now what I would say is I'd say, okay, since a is continuous on the closed, I'm emphasizing closed interval by saying closed interval 0 to 1,000, the extreme value theorem applies. Now, what is that saying? The extreme value theorem says that if you have a continuous function on a closed interval, then you're guaranteed to have an absolute max and an absolute min. Now, we know that these can occur either at endpoints or critical points. We call those our candidates for extrema. So what we're going to do now is we're going to test all the candidates. All right, so I'll make a little table here. So we got x and a of x, and our endpoints are 0 and 1,000 and 500. All right, so now 0, we kind of know what that's going to be. You can see it right here, right? If x is equal to 0, 0 times anything real is 0, so you're just going to get 0 there. So that's one of those degenerate rectangles that we talked about, where it's just one all y fencing. But now at 1,000, that would make y 0. So that would be like all heavy duty fencing. So that would be the flat degenerate rectangle. So that's also going to be 0. And then at 500, we have to actually figure out what that is, right? So what do you got? You're going to chuck 500 in. You're going to get 500 times, we'll just chuck the calculator really quick. So it's going to be 1,500 minus 3 halves times 500. And we end up getting that. All right, so 375,000. So obviously that is your max because that's bigger than 0. Okay, so we'd say, okay, A has a max area of 375,000 square, what are we using here? Feet? Yep, square feet. All right, and then we'll say with dimensions. So what are the dimensions? Well, it's x by y. So it's going to be 500 by whatever the y dimension is. So again, I have an expression for y. I can just chuck in the 500 there. And if I end up doing that, I will get 750. Okay, so there you go. So there you have it. So pretty solid little question. I'm going to stop the video before I do the next one, question 9, which looks like it's very similar, but it's actually like a little twist on this question. All right, so hopefully everyone's good. Talk soon.